in my function as OSGi evangelist, this is going to be my last OSGi presentation. So you're witnessing an historic event. I think it's been largely unnoticed. At least I haven't seen a lot of blogs and people talking about it. But in our previous release, 4.3, we formalized a concept that has been in gestation for, 6-7 years. About 7 years ago, Richard Hall and I wrote an RFC that completely illegally did not have an RFP. And against all customs was actually published before it was a spec. So it was a very extraordinary RFC. It was called OBR, the OSGi Bundle Repository. I can tell you a lot about it, but I actually want to share a little experience I had a few weeks ago. Anybody playing? What's happening here? Somebody mucking around with my computer? I saw that. I don't know what's going on here. I think somebody's trying to hack my computer and was successful in it, which is quite scary. Anybody playing around with Node.js, the JavaScript engine on... there's some people do it. Now, I did this as well. What you do in Node.js, you install a Node package manager. Really trivial. You can actually do it from the command line with a URL, with curl. It installs it, runs it, installs. So you don't really have... It's very simple to get NPM started. Once you get it started, you have this wonderful new environment that you have a prompt. And from the prompt, you type a command. We all know that feeling, oh shit, now I have to go down the internet, I have to do all that nasty work to get it installed, to get all the dependencies in place. Hopefully there is some package manager that does it. Well, Node does that like some of the other package managers does it as well. You just install CoffeeScript and it installs it, and at that moment you can just execute the command. WTF, I will, as the evangelist, not use the real words for it. Why can't we do this with Java? Did you ever try to make a command line application in Java, or something that you could just start in Java and try to run it on the PC and all these other environments? Why can't we do this? We somehow, Java is supposed to be about platform independent and that you can do those things. We can. Now the key thing, that if you want to do this, and I really would like to do this, is that you run into this big problem, you have to manage dependencies, and that's a big deal. If you're going to run dependencies, then we immediately, but we already fixed that problem, didn't we? We have Maven, which is doing dependency management, but I cannot really do what CoffeeScript can do, or what the NPM can do with Maven. We have P2, which is, everybody knows what P2 is. We have Ivy, we have a couple of other ones. Let's take a little bit more of a look, because I do not think that not one of them is really doing the whole story. If we really want to make this automatic installation work, and not just for one environment, because in Java we have all these different environments. We have a very rich world with different kinds of requirements on that world, with different kinds of capabilities in the environment that you run into. So let's take a look at what's happening if we want to make this work in the Java world and do it the right way. I think the key thing that you find is you get dependencies. And we have a dependency in the world, we want to do it as simple as possible. So what people are doing is they create their own artifacts and they put a dependency on the artifact. In the real world, that is a little bit untrue, because when you look, for example, at Maven, and you depend on an artifact, you do not really depend on the artifact. You really depend on what is inside that artifact. If you think about that model, it's the internal references in your module that are the real dependencies. But we do not express that in Maven. What we actually are doing, we're causing a self-inflicted pain. Not just Maven. Most dependencies model works that way. I don't want to blame Maven, because Maven is doing Actually quite an impressive job. But the model is fundamentally broken because we create an additional namespace for our artifacts. And then we have to manage that artificial namespace. And there's a mapping from this artificial namespace to the real, actually, underlying dependencies, what we really depend on. And there is no verification between the two. You can make you can refer to class foo.a in your artifact. And there is absolutely no guarantee that the artifacts that you require to be on your class path actually contain foo.a. It's the names that you use in your ponds are names that you invented or other developers invented, but there is no relationship to the underlying things that are really causing the dependencies and that are really need to be there in practice. And I tell you a little secret. We suck in that. We are really, 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 really bad in managing versions and managing these fine-grained dependencies. That's something that computers excel in. They're really good at it. They love it. We suck at it. Let's take one example. And as the author, primary author of B&D, I can tell you that if you look at a class file, there is a wealth of information in the class file of what you really depend on. Because if you do an import and if you use a class, then from that class file you can really find the actual dependencies of what that class is referring to. And the nice thing is that you said it, do not repeat yourself, that's the Agile motto. You only have to do it, you already did it, it's already in your source code. So that's a good thing to model. So that is one of your fine-grained dependencies that you want to take into account. But there is more. Last week on Stack Overflow, there was this question. This guy got the really awful job of working with XSLT. Sorry?
There's nothing awful about that.
Okay, yeah, well, there's not, I don't think
it's an achievement, you know, when you make
I guess you get some badges for that, being able to program XSLT. Actually, I am quite fluent in XSLT, and I can tell you it's the worst programming language that anybody has ever designed. Actually, it should be in the Human Rights Manifest. Actually, I think it's one of the few write-only languages.
Yes, that's true.
Anyway, when you look at XSLT, you can actually rely on other XSLT sheets. You can compose it, you can modularize it. Then you get a dependency model. Again, you get the same thing as what you saw with the class files. You got some resource that has dependencies on other resources. And this is perfectly solvable in OSGi. You can easily put your XSLT style sheets in a bundle, but you have no real way in OSGi to express that dependency, or you did not have a real good way to express this kind of special dependency. But there's more dependencies. If you look at OSGi, then who's using declarative services? Did you ever sit there for about half an hour or an hour figuring out why the freaking thing wasn't working, only to find out that you had not installed declarative services? It's such a stupid mistake.
Not just half an hour. If I aggregate over 6-7 years.
That is a dependency. Again, it's another type of dependency. It's a package dependency. It's another dependency than XSLT. But it is a dependency that a bundle actually depends on the extender. And it's one of those things that very unexpectedly bite you in the ass, because we did anything, and I've been advocating this model so good, because it is completely decoupled. Yes, it's completely decoupled, and that's why you spend how many hours figuring out this? Because there is actually a dependency. Now, I'll take one more of those. You have certain software that runs well on a big screen, and certain software that runs well on a small screen. The thing is, we're not talking just about software artifacts. We're actually also talking about physical artifacts. There might be bundles that require a USB interface. There might be bundles that require a Bluetooth interface. There might be bundles that really need a big screen. Nightly bundles that need some native code availability on the platform before they can run. When you think about the world that way, you really would like to have clear message when something shouldn't be run. Neil can translate it.
Some of it.
I think it's one-way street or something like that.
No entry, no cars this way.
Yeah. Neil's wife is Japanese. You really would like to have a model where you can express your dependencies, and you don't have to assume that somebody creates another name layer and that all these aggregate dependencies are hopefully satisfied when you deploy your code. But you would like to have a language where you can take a resource, a bundle, and say, this is what I really depend on, and this is what I provide. And that together it is taken, at least that before you run it, you get a clear message. When you look at OSGi, and for me that was a bit of an insight as well, and actually for me the biggest surprise is how wonderful this model is backward compatible with what we have done over the past 14 years. It's even actually, I'm very impressed about that. If you look at the diagramming technique in the OSGi manual, it's completely compatible with the generic requirements capability. We use the same, well, take a look at the spec, you will see that. So when you look at what we did, is we said there are requirements and capabilities in this RFC 112 we wrote 7 years ago. A requirement is a filter. And the P2 guys looked at it and said, oh my God, that's so inefficient. It's impossible to work. We'll do it differently. There was actually some looking at OBR at the time, but unfortunately they didn't take it. But I think a requirement is crucial. Because how can you specify a requirement on an absolute value? Let's say that you need a printer and you need to print a document of 250 pages. You cannot look for a printer in the network that has 250 pages because it might have 251 pages. Does it mean that you can't use it then? The magnitude comparison, being able to say, oh, but I need a printer that's more than 250 pages, and it needs to be able to do color printing. You cannot specify a requirement by having just properties that need to do an exact match. You need to be able to have complete expressions on that. Think about how a database would look like if you could only do attribute assertions and not do any comparisons. So a requirement is a filter. A capability is a set of properties. It's not one property, it's a set of properties that you do a match on. So the filter gets applied to the properties, or the attributes as we call them nowadays. And if it's true, then that capability matches. A capability and a requirement can only match when they happen to be in the same namespace. And what is a namespace? Namespace is basically the type of a capability and a requirement. What the namespace says is that if I use a directive here called XYZ foo, then it really means this. If something in this namespace gets wired, when you create a wire from that requirement to the capability, then it really means package loading. That's, for example, we have a set of namespaces in the OSGi that map exactly to the existing manifest headers. Import package, require bundle, fragment host, and identity to a certain extent. They have meanings. But the thing is, we did not, it's completely generic. You can actually, in the specification for the resolver is the one that creates this wiring. Or actually I wrote in the spec, it didn't make it into the final draft because it was a bit too big. A dependency injection framework based on this kind of requirements capability, because you have the wiring information available. So how does that look like in the manifest? This was introduced in R 4.3. All the frameworks that are currently popular, Equinox and Felix, do support this out of the box. You can provide the capability. What that means is that when your bundle gets resolved, which means all its requirements need to be satisfied, it's a recursive definition, then it will provide the capability in the namespace OSGi.contract. This is a property, OSGi.contract equals Java EE, and the version equals 1.6. It provides a foo.screen with 408, 400, it defines a bar.xslt with some properties. Those properties are not just for matching. They can actually be introspected in runtime, and you can base your code on it. So these are capabilities that can be provided by the bundle. They can be also provided by the environment. On the other side, we have require capability, again, a manifest header. For example, this is a bundle that wants to have the Java EE contract. It's a filter that says, I want to have, I actually think the ampersand should have been in front. It's not a valid filter. It's an, I want the contract Java EE, and it should be version more than 6 and less than 1.7. That's the version range that you're going to select on. I need a screen that's more than 300 and by 300, and I need a bar.xslt. So you have suddenly a very rich language to express all kinds of dependencies. And this is not something that is toyish, because we were able to completely map the OSGi semantics, all the manifest headers that we have today. We could map them to namespaces in the OSGi wiring namespaces. Now, the best part of that is that we now have resources that describe themselves. If you look at the resource, if you parse the manifest, you have all the information to say, this thing can only run when I get these capabilities from other bundles. So if you have a repository, then you can take the requirements from a bundle. You can go to the repository and find all the capabilities that you need. And that's not a one-to-one mapping. But the cool part is that it is not just that you create a single resolution. You can take information like the screen size, for example, from the environment into account as well. You can take preferences into account, and then you can resolve the whole picture and find all the resources that together form a closure where all the requirements match the capabilities. That's an incredibly powerful model. The reason I was so enthusiastic about it, or still enthusiastic about it, is when I got started, Windows 95 was the most common operating system. And I utterly hated it. I thought it was absolutely horrendous. But the bad thing that was happening in the industry was that people said, oh, Windows is going to be there forever. How many people still have a Windows machine here? Oh, we have a few left. Most of them. Actually, a friend of mine picked me up yesterday and he said, I've never seen so many Macs in my life. But at that time, it looked like the whole industry was going to go to the PC. And the problem was that developers were saying, well, I'm only going to develop for the PC because I'm not going to carry it to port it to Linux and to Macintosh. There are not enough customers for that. But I think it's crucial, especially in Java, that we actually can make deployments that we do not require the developers to prepare their applications for all kinds of different environments, but that they can specify their requirements on the environment, and that if necessary, other people can provide the capabilities to make things work on different environments. I think that's the promise of Java, and I think we're pretty close to that. So the key thing in the repository is that it's not as a developer that you make a binary for Windows. You provide something that has a certain set of requirements, and that are done alternative ways, and might be later in time, for people to put the missing capabilities into place as well. So you create a much more decoupled system. When you look at OBR, we specify that repository, we specify this completely generic capability requirement model, and we also specified an XML file, which allows repositories to communicate with each other. And again, this XML, I don't go in there at the moment, is completely allowing you to specify the complete generic capability requirement model for any resource. Because the cool part is that we're not talking just about bundles anymore. The capabilities were generic, the requirements were generic, but if you look at the specification, we only talk about resources. And a resource can be a bundle, it can be a subsystem, it can be a certificate, it can be an XML file, it can be even an XSLT file. Every resource can specify its requirements, capabilities, and the resolver will actually find a set of things that are working on a system when you deploy it. So it's a really powerful concept. I think it's incredibly innovative. I don't really know anything out there that tries to do this. And the cool thing is actually all the key parts are already in the framework. And you can already use it. And we really, in release 5, the latest release, we put some API around it that makes it incredibly useful. And interesting, while we had that developed in release 5, we started to take advantage of it. And we actually did, I think we added 4 or 5 namespaces in release 5 that have specific semantics. The extender namespace, the contract namespace, identity namespace, the content namespace, the service namespace, and the service loader namespace. So yeah, so this is really one of the most innovative things we're doing. And the whole idea is that we should be able to do this. Good. Any questions?
Capabilities and requirements change over time. For example, the capabilities and requirements of a particular set of software and application change over time. And the current example you use is a good example of that. Because in some time you may, for example, a particular print job may require 250 pages, another one may require 300 pages. As the printer itself runs out of paper, it no longer provides the capability
Exactly.
to match those. And I mentioned something about meeting capabilities and requirements at runtime. Does that also lend itself to deactivating?
Currently, if you look at the model, I didn't talk about that.
Paraphrase that.
Okay, yeah. The key question is that the example, well, some of the examples that I gave were actually dynamic requirements and capabilities, and others were really static requirements and capabilities. When you look at the OSGi framework, then the resolving is done statically. They're done at resolve time, which means that the whole purpose of the module layer is to enable the service layer. So the module layer provides the fabric on which the service layer can exist. But once you're at the service layer, you get the dynamic dependencies. What the generic required capability model has is what we call the effective time. When is a requirement and a capability effective? And you can actually set that. In the OSGi Alliance, we have defined the resolve. So this effective time is resolve, which is the standard OSGi resolve as we know it today, and we love it today. But we actually have foreseen that you can also use that same technology and actually the same resolver also dynamically and do things dynamic. That's currently not in place, but you could already do it with the current APIs, but you would have to handle it yourself. So yes, we can also go to other effective times.
Is the effective time, is that mutable, or is that always set?
I'm not sure I get the question.
I'm actually wondering how frequently I could potentially pull from you requirements.
Well, I think.
Can I jump in here just a thought?
Yeah.
I actually think that the example of using the number of pages as a resolve time, requirement is slightly contrived. And I would model it as an ordinary service.
Exactly.
With a service property, no resolved effective time or whatever, just the service property, and then you can have listeners that listen to any changes of those service properties. So if the number of pages changes, you can get a callback and you can react to that. I think that would be
Yeah, I think I was going the same. Yes, but I think it's the same model. If you look at the service registry, which the properties, what David is pointing out, it's exactly the same model. You specify a filter.
Yes.
And if you want your printer to be more than 250 pages, then you specify that in your target, in your declarative service, and your service is only available when there are 250 pages available. So the required capability model is mainly oriented towards dynamics, to the static part, to the resolve part. You can actually use it with dynamics, but the services are already handling this very nicely. So these kind of use cases, as the printer, I agree, it was not a good use case. But it was always a good use case to show the magnitude comparisons. Sorry.
Right, the number of sheets in the printers maybe not such a good example, but if you are in the car industry, you are asking, is there a printer available that can print a 4 meter long and 2 meter tall drawing?
It's the key thing. I use that example only to show that in the real world, you need to be able to do complex expressions that do magnitude comparisons, because the assertion that an attribute is the same as another attribute is too simplistic. So that was the reason, but yeah. Okay. I saw you first.
What version of generic capabilities? Capabilities provided within the OSGi wiring namespace. It's tied to the semantic versioning, which is basically Java ABI and ABI compatibility. How can we version generic capabilities?
The question is, I'm learning, even I'm learning. The question is, can we use semantic versionings with capabilities? Because the semantic versioning models put rules on how you actually evolve something. So in this case, a capability will always be versioned. Like an export package, it has a version, which is always a single version. But then when you do an import range, semantic versioning gives you rules how you should calculate your range when you have a capability that you want to depend on. So you depend from 1.4 to 2. Yes, that's fully supported. And the namespace has to specify that. The namespace can specify that one of the attributes is a version. Attributes have types, so it can use the version object. And then the namespace can also specify that the version should be semantically versioned. Now, all the rules about that stuff is in namespace. And somebody will create, will have to map the description to a repository format, for example, the XML. And there they will have to create the filter expression that implements the semantic versioning. So, long answer, but yes, semantic versioning is fully supported because it's quite crucial. That's a great question.
I just wanted to ask you the previous point. So I guess that this language, this constraint language, is really against the resolver or something that's one function of it, implementation, right? So that's basically the target.
Yeah, well, no, it isn't. That's one of the use cases. The key thing is, and I think that you'll find that I forgot to repeat the question, and now I lost the question.
It wasn't really a question. I was just sort of verifying if that's
right. Let me just answer it. That's probably making it clear what the question was. 42. The key thing in OSGi is that we try to be modular. And when you're modular, you can always express your requirements because you are the best person in the world to know your requirements because you have them. And others have the capabilities that provide that. And I now really lost what the question was, so. Good.
All right. Based on your previous example on Nathan and how we could not really map at this other layer, which is basically the jar layer, down to the capabilities that you provide. Now, you also have another example talking about dependencies between Excel spreadsheets, for example, right? I see how we could easily map the capabilities in the Java world using tooling, but outside the Java world, let's say if you are dependent on a resource, let's say an XML resource or whatever that's in there, how would you tool it so that you really make sure that the capabilities provided are available in that bundle?
Basically, the question is, how could you automate the generation of the metadata? Yes? That's right. And in the Java world, we know how to do this with class files. With XSLT, and actually, I must admit that it's the first time that I see an advantage in XML, that they use XML and XSLT. You can actually write an XSLT style sheet that reads the XSLT program. It gives you all the information what it depends on. And actually, if you look at BMD, it does this on the blueprint and Spring files. Those are XML files. Those are parsed with an XSLT style sheet, and they give you all the classes that they have a dependency on. So in virtually every electronically readable format, you can actually calculate the requirements that you depend on.
It depends on whether that format provides facilities for you to even read the
I think, and I'd love to have the discussion, it's intuition, I can't prove that, but I think that is actually always the case. I think it's impossible because even if it's implicit, then you can take the implicit. But there must be, when you get deployed, you're going to use stuff. And if you don't know what you're going to use, then, so there must be a relationship between your actual dependencies. So at least in my experience, you can always automate that if you have a machine-readable form.
Bindex is pluggable to understand.
Exactly. Well, yeah. Bindex is the tool. Yeah. Okay. Thank you very much.